Right, ladies and gentlemen, let's get started. Let me tell you what I'm planning today. You'll notice that there's no lecture such and such slide up. It's a different lecture today. I'm just going to go through a couple of places where I feel it helps to have a sort of pointed review done. I'm hoping that for those topics, after this review, you won't need to spend much more time. You can spend your time on other things. But before I do that, I would like to go through some details of the exam. Friday is going to be different from other days, yes? So, based on what was discussed last time, when you come in, what time are you going to arrive on Friday? Yeah, you're all going to be outside there, 10 o'clock. Now, I'm going to tell you, I say this to the people who are in the room. The people who are in the room are a self-selected group of people who come anyway and know what's going on. It's the other people that I need to reach. I have no way of reaching them other than I'll send a couple of emails. So you will get emails saying things that you already know. But also, on Friday, you will see people you and I have never seen before. Okay, so everybody shows up at 10 o'clock, and then once, whatever chemistry class has left, what are you going to do? You're going to come in, and then what are you going to do? You're going to come this way, yes, and I'm going to have, and then you're going to go in this way. Yep. Regardless of where you normally sit, you are not going to push this by saying, I'll just sit here. Everybody else will take care of it. And they're not going to be mean to me. We are. All right, it's an exam. We take it seriously. So the GSIs will be sort of, pointing people to where they should go. But please, it's 500 people and you need to start an exam on time. Don't be the reason the exam starts late. All right, so then as soon as you are seated, we will hand out the exams. You will fill out your name. You will not turn pages and so on. We hope that, by this method, we will get people seated expeditiously. And the exam will start at 10:15. I will say that should you be seated earlier than that, if everybody's seated and you all have your exams, I'll let you start whenever we are all seated. So it is in your interest to cooperate with the seating process. I will know where everybody is sitting. We have a way of having you sign in by row, and we will know where everybody is sitting and so on. There are multiple versions of the exam. Please answer your questions, not the questions of the person next to you, because the people on either side of you will have different questions. All clear? All right. So I do have to say this. I hate saying this, but over the past 5 years, it has been an increasing problem to the point where faculty can't ignore it anymore, or say that it's just I'll take care of one or two people. This exam is worth how much of your grade? 10%. It's not worth a lot of your grade. If you are considering doing anything nefarious during the exam, think about this. For 10% of your grade, are you willing to jettison your decency? You are not. You're not that person. Right? Just the questions, if you put your minds to the questions, you will be able to answer them. Right? So just focus on the questions and not on anything else. Please, bring your photo ID. Everybody got a Cal ID? Yes? All right, so either that or a driver's license, please. We have to check that as you are leaving. Let me explain why we have to check that as you are leaving. Look at this. It's the day before the exam. Welcome, all these people. Look at this. Wow. And I'm not even the sort of the professor who tells what the questions are the day before the exam. Never mind. All right. I'll tell you why we check ID. I'll give you an example. A couple of years ago, one of the statistics department graduate students emailed all the faculty a post to Craigslist. It was under Craigslist jobs. And the post ran as follows. I am taking a summer statistics class at Cal, and I need somebody to take the final for me. And there was some, date and time. There was some information. And so, people in the university dealt with this. What I regretted was that person didn't say what it was worth. Right? How much was that person paying? as this job for somebody to come and allegedly take the final for them, right? Because I was thinking, well, if it's, should I take it? I mean, anybody can sign up, right? It wasn't my class. But anyway, look, people do incredibly stupid things. I had a student, I was teaching, and that was a smaller class, about 100. When there are 100 students, I know everybody. And during the exam, there was this one person whom I did not recognize. So I walked up to him, and I said, can I just see your name, please? And I saw his paper, and there was a name of a student, and 100 students, I know them. And I knew that student, and it wasn't this person. So I said, this student, that's... And he got up, and he left. That it was gone, and the paper was on the table, and so on. So people do incredibly stupid things, but you are much smarter than that. What you are going to do is you're going to look over the textbook, you're going to look over the homeworks, you're going to show up, and you're going to just address the question in front of you. It's a 5-minute Data 8 question. You're a smart person. You can address the question. Tell yourself, sometimes things happen in exams. Students call it freezing. Okay. If that happens to you, please tell yourself, I do not need to do this whole exam. Right? I need to do one question. Flip through, find one question. Do it. The tension starts to dissolve. Flip through, find another question. And work in that way. If you tell yourself, I need to get to question X by time Y, and by the time you are getting to question X, you haven't been able to do question W, or you are thinking, then you will mess yourself up. So just, if you do the exam with your own relaxed frame of mind, you will be just fine. And I think if you take a look at the last time's exam, you will see that the questions are not surprising. You just need to sort of organize yourself and say, okay, so this one works this way. Right. Now, look at this room. We aren't even all here, but there are many more of us here than we normally are. But already it's pretty full, yeah? So I am going to request that bathroom, water drinking, and so on, please, could you just take care of that before you come to class? Please. Please. Because it's going to be really difficult. There are no aisles in the center here. All right, so please, just take care of that before. And regretfully also, I have to insist that you not leave in the middle of the exam. Because there's a lot of climbing over people's legs, and that bothers a lot of people. So just sort of hang out there, sleep. If you are done in half an hour, great, sleep, please, so that we don't have 20 other people bothered. So we are now sort of through the exam. I'll talk about the end of the exam in just a moment. Up to this point, do you have any questions? Anything unclear? Yes? Okay, no. We're talking admin. Have a seat. Okay. More. Hold that question. We'll come back to it. Anybody? Yes? The practice midterm is part of the business of the labs today and tomorrow. All right? So that's last time's midterm. Also, they have questions from John De Niro's midterm from last spring, the ones that are applicable to us. He had a different sequence. And they have assorted slides and so on. So today's lab is not a lab. It is just a whole set of questions for the midterm. More questions? Okay, what will be in front of you on the exam will be a packet, which is the exam. It's a stapled packet to the front page you have seen before. It has, you put your name and your SID on it. Then there are 8 pages, 1 page for each question. I have, just to be out of an abundance of caution, asked you to write your name on each page. There's a place for you to do that. We are going to scan these exams, and just in case something bad happens with the scanner, I need to be able to identify each page. So please, before you start a page, just blindly put your name down. All right. You will also have a separate sheet, which is the 2-sided reference sheet, which you've looked at, yeah? We've cleaned it up a little bit. That reference sheet, on the one hand, isn't meant to be exhaustive. I mean, we have used those methods on the second side in various different ways, but it's pretty darn complete. And so you don't actually have to worry about exactly what the order of the syntax is and so on. On the front side, there are sort of somewhat more conceptual discussions. And in the end, I don't think there are details on the exams, like technical detail, that aren't properly discussed there or aren't discussed at all. The issue will be concepts, right? So that's what you have to think about. All right, so then you work away. Listen up. I do not answer questions during the exam. Right, so the hands that get raised, basically asking for reassurance, have you understood the question correctly? In a room this big, not possible, especially for the people who are in the center, and I prefer that the person who keeps asking for reassurance doesn't get an extra benefit on the exam that the quieter people don't. So read a question. Make up your mind about what you think it means. If you are doubtful, say, oh, I'm picking this, I think it means this, and I'm answering it that way, just answer the question. If you feel there is actually an error on the exam, there won't be, but if you feel that, then raise your hand and I'll ask you to come out and show me the error. Okay? But the exam is being read by multiple highly expert people, and we hope that it's going to be just fine. I haven't had this problem before. But what I will do, today, the actual review, what I will start with, are the kinds of things that bother people in exams that don't bother them at any other time. Right? What happens is when an exam is in front of you, then tiny little things start to become moments of panic, which rationally you would just deal with. All right? So I am ready to... No, I have one more thing to say. The end of the exam. We will give you direction. There will be a moment when the exam comes to an end. If you are writing after that moment, I'm really sorry to say this, but that's actually cheating. Don't do it. So we will try to ensure that we have a way of picking up. Note that I will know everybody, where everybody is. I will be able to record where everybody is. We will see whether you are complying with the instruction or not. And what I do in such cases is those exams, I don't even grade it. I put a 0 on it and I hand it back. I've done this before, even last semester in Stat 134. It's not worth the extra 1 or 2 points that you thought you were going to get. So when you are asked to stop writing, do what 99.99% of the students in the class will do, which is stop writing. We're going to try to get you to move your hands to a place where you actually can't write even if you wanted to, but we'll sort that out. But please comply with that instruction. I am not the kind of professor who will let some people keep writing when other people have followed the instruction and stop. Right? That is a very, very serious risk that you take. Now, in my Stat 134 class, there was a clobber rule. The final exam grade killed the midterm grade. You don't have that. So stop writing when you are asked to stop writing. Can I be clearer than this? All right. So, we hate talking like this, but we have been forced to over a period of years where somehow, for some reason, students haven't cottoned on that exam rules actually matter. But now you know. All right, now, end of exam. Your questions about the conduct of the exam, anything during the exam, anything that you need to know. Content, another matter. Yes? Another time. As he said, this is only for a few people. So I'll take it separately. Okay. Anybody? All right. So does it sound like an exam that is reasonably easy to figure out what you have to do? Yes, you have to show up, come as far front and as far center as you can go, take out that pencil and address the questions in front of you. Stop when you're asked to stop. Sound good? Excellent. Okay. So I want to start with, you'll see that I have a bunch of stuff in my notebook, but I want to start with the kinds of things that bother people in exams that don't bother them at any other time. People get terribly worried about stuff like this. Okay, what does that mean? 7 or more. All right, what? Yes? All right. Why am I doing this? Because every exam somebody asks me, right? And I tell them, look, I don't answer questions, so you should not be, etc. Everybody clear? All right. There is one issue that, if left unaddressed, is ambiguous, and that's the word between. All right? So there will be, if I use the word between in an English sentence, then that will be defined, so between 2 and 7 inclusive, include both endpoints. All right? But what does Python do? Between for Python means what? Include left, exclude right. Yep? Okay, so this is in your cheat sheet, but I'm just saying it. What's another place where this comes in? Excuse me? Ranges, yes. Include left, exclude right, yes. What's another? What's a data analysis place where this comes in? Bins, histograms. When you do bins equals whatever list, whatever array you're specifying, what hist does is it groups the data, and every bin includes the left, excludes the right. So that is what in technical language is called, there's the endpoint convention for Python is intervals include the left end but not the right. All okay? So we have been consistent throughout the course. It's just at the time of an exam, this sort of frazzles people, and I just want to be clear that you're all confident about this. Any questions about this endpoints? We're not going to suddenly shock you with switching endpoints around. All right, good. Okay, so now I actually want to get, my agenda today is there are two things that I want to do where I feel that I can actually finish your review right here. And then I will take questions. So I want to talk about histograms, just to make sure that people understand the scales. And then I want to do a quick review of basically every type of probability calculation that you have done. And then I will take questions. We've talked a lot about inference. We've talked a lot about hypothesis tests, p-values, errors over and over again for a long time. This is somehow from some time ago, so I'll bring this back. I'll bring this back, and then you can ask any question you want. Does that sound like a plan? All right. So what is the difference between the key difference between a histogram and a bar graph, please? The type of data. Categorical data, bar graph. Numerical data, histogram. All clear? All right. So both try to visually represent distributions of data. Now, I want you to focus on numerical data, quantitative data, and think about that horizontal axis. That is where all the data lie. The data aren't everywhere on your page. They're on that line. They are constrained to that line, right? A distribution shows you how concentrated they are in various parts of the line. Okay, so if the points were evenly distributed, then the distribution would be flat. You agree? If they were evenly distributed from the min to the max, then the distribution would be flat. That's called uniform. But most interesting distributions aren't flat. The reason they go up and down is that there is more crowding in some areas of the range than others. Up and down, crowding. Height measures crowding. All okay? So what we're going to be looking at is so now actually we can start reading this. Okay, so quantitative data. Okay, if it's quantitative data and you want to understand it, your numbers have to make sense. The relation between 5 and 10 has to be the relation between 5 and 10. It can't be the same as the relation between 1 and 2. Okay. So numerical axis, you've got the number line on the bottom, and okay. So what the eye picks up as big is area, not just height. Bars are allowed to have variable widths. And so the areas are proportional to the number of entries in the bin. Okay, what does that mean? Proportional to the number of entries in that bin. The area is, therefore, the number of entries in that bin times any constant that you want. Right? And the typical constant is what? Number of entries in the bin. What do you do to that? Divided by the total, convert to a proportion. Yes? So proportion of entries in the bin is the area, and you can take that number and multiply by 100, and now the percent of entries is the area. So there are three equivalent natural ways of coming up with the area in the bin when you are drawing your own histogram. One is the number of people, the other is the proportion of people, much better, and because it takes into account the total number, and proportion and percent are genuinely equivalent to each other. They're it's a decimal point movement. Yep? Okay. And so the height measures, as we just said, I'm just going to keep saying percent because that's what HIST does by default. The percent of people per unit space on the horizontal axis. Right? In that sense, it is a density. Now, you are used to thinking about population density as a number of people per unit area, but you don't have, the space isn't areas here. The space is the number line. Everybody is standing on a wire, and the height is measuring the percent of people per unit on the wire. That's what it's measuring, and hence it is measuring crowdedness. All sound familiar so far? Okay, so I want to do a couple of things. So quantitative data drawn to scale, area of bar, height. Okay, it's a rectangle. If the area is, if you've got the area and the width, the area is a percent, you can figure out the height. Density scale. Okay, so density scale. Density scale means the total area of that histogram is 100%, which you are welcome to call 1 if you wish. Okay, that's what it means. So you haven't left anybody out. Height measures crowdedness. Okay. So now, if you are to combine two bars into one, then you have to figure out what's the total percent in the two bars. And to draw one height, you have to say, okay, what's the total width of those two bars from left end to right end, and then figure out what the height has to be. If you are going to look within one bar, right, then you either have to make an assumption or you need more data. All right, so the standard assumption that is made, our histograms have flat tops. And that's kind of the tacit assumption that's being made is within each bar, the entries are evenly distributed across the area, across the width of the bin. And so then under that assumption, the percent in the left half of the bin is half of the total percent in the bin. Okay? But that assumption might be out to lunch. The wider the bin, the more you should be suspicious of that assumption. You all agree? Okay. If you are going to work within bins, you're going to split a bin into two, you need to know how many people are in each portion. And if you know how many people are in each portion, then it's just a bin like any other, and you can work with it. So if you see a calculation done that says, okay, so I've got this bin from A to B, and I'm looking at the last third of the bin, right? And I say that 1/3 of the people are in that bin. That is not exact. That is an approximation under the assumption that within the bin, the entries are evenly distributed. And this class, we keep hammering, what's exact, what's approximate. if it's approximate, under what assumption, and so on, and that's what you need to focus on now. Right? The calculation, most of you can do quite easily. So I just want to look now at the units of the height and make sure that you have some physical way of dealing with the units, and if we change units, you don't have to worry about, I forgot whether I have to times or divide. Okay? So let's just, I'm going to give you a couple of questions. Okay, so variable. I have to tell you what the variable are. I'm just going to say the variable is length measured in inches, and height of a bar is, let me give you something awful, 0.043% per inch. All right, please take a look at that. 0.043% per inch. It's percent per inch is the unit of measurement of the height, not percent, even though percent is right up against the 0.043. Okay, so take a look at that. 0.043%. Yes? Is that 4 out of every 100? 0.043% is what? It is 4 out of 10,000. Yeah, it's very small. 4.3% is 4.3 out of every 100. Yep? So this is already in percents. That's the first thing to keep in mind. Don't start converting this yet again. It's already in percents. It's a tiny percent. Okay. All right. So now what I'd like to do is I would like to say, so suppose now you measure the lengths in feet, and we have an international class, and I have learned that I cannot expect people to know what a foot is. I don't know how many times I have had people saying 1 foot equals 10 inches, and therefore. Okay, guys, USA, 1 foot is how many inches, please? 12, thank you, I feel much better now. Okay. I'm going to measure the same lengths, but in feet, and I want you to be completely clear about what that height is without having to memorize, do I times or do I divide? Yes? All right, what are the units going to be, please? Before the number, what are the units going to be? Not feet. Percent, not percent per inch. Percent per foot, thank you. All right. So how many inches in a foot? 12, we said, right? So for this bar, what percent do you have for 1 inch? 0.043. Yes? What percent do you have for 2 inches? For each inch, you have 0.043. Therefore, for 2 inches, you have 0.043 times 2. For 3 inches, you have. Okay, for 12 inches, you have. Thank you. All clear? Does this need a memorization of whether you times or divide? It needs an understanding of what something per something means. Right? For each inch, you have this much. Now you count how many inches you have in your new thing. All okay? All right. I have not seen students have difficulty with any other aspect of a histogram. So I'm going to shut up, and I'm going to take any question that you have about histograms. My object today is to not do code, but if you want code, we can talk about it. Oh, I should tell you one thing. A number of students have asked me. In the histogram lecture, I did a method called bin, which actually does binning. I'm not going to ask you to do that. Right? You haven't had homework on that much. You haven't done that in your project. I'm not going to ask you to do that. Right? You are also not going to have to make decisions about which bins to use. Those decisions will have been made for you. You just have to work with the bins that are given. Yes? So people are worrying, a lot of people have asked me, and it's a deep question. How do I choose bins sensibly? That is a very serious question, and far too serious to be able to address in 5 minutes on an exam. Okay, any questions about histograms, please? I'd like to move on. Good? Yes? On the y-axis, the only diagrams that I'm going to give you are diagrams produced by table.hist. Table.hist gives percent per unit on the horizontal axis. That's what you're going to get. All heights are measured in percents per unit on the horizontal axis. I'm just sticking to what you get from hist. More questions? Thank you. You cannot see the sample size by looking at the histogram itself. Remember that the histogram is measured, the areas are measured in percents. Right? So if all you know is that if the sample was size 100, then this number would be here, this number would be. You cannot tell sample size by looking at a histogram. More. Yes. Yes. Mm-hmm. Okay, so let's be clear about what we're saying. So the question is, if we randomly sample, so we have, say thousands of, what are we doing? Thousands of links, and we randomly sample 20% of them. The random sample is a data set in its own right. The histogram of that sample treats that data set as 100%. So you'll be drawing the histogram of that sample, not that sample with some, other bunch of stuff left out in the population. Each histogram treats the data set as the complete set. More questions? Ask now. Might as well. You got me. I'm willing to answer anything. Yeah.
If you had a population of, let's say, am I allowed to talk about the tax
No, that's for the lab.
Okay,
So if you can, if there's a question that you want to raise that is more general, then ask. But yeah. When we are drawing a histogram from a table, when do you need to specify which column to draw the histogram of? When your histogram has multiple numerical columns. All right, so if you want to, your histogram has income, age, height, weight, and you want to draw the histogram just of the incomes, then you have two ways to do that. Either you can do table.select income.hist, right? Or you can do table.hist, then name of column, and so on. We have almost invariably in class done the former way. Extract out the data that we want to use, and then draw the histogram of that. More questions? If you do more than one column, you get overlaid histograms. And you have to be careful, because if you have incomes and heights and ages, yes, they are all numerical, but the units are all different, and it makes zero sense to overlay histograms. All right. More questions? The histograms take a surprising amount of time, but what happens is when we get to putting continuous curves over histograms that have bars, then the fact that you understand very clearly that it's areas that are the proportions become very, very important. So we start with densities from the beginning so that you can generalize and get to finer things easily without having to have a new thought. Right. We all set for probability theory? So my idea is I'm just going to go through 9 or 10 problems, and hopefully that brings up all the issues that we need to bring up. All okay? Okay, we're just going to do this. All right, so terminology. At random means uniformly at random, so you shuffle everything, pick one, each one has the same chance. Cards dealt from a deck is you shuffle, deal at random without replacement. You don't have to worry. I don't remember what the deck is. I'll describe decks to you. if there are cards dealt from a deck. I can't remember whether on this exam I just say coin or die without saying fair, but if you have a coin or a die or a roulette wheel and you aren't told, it doesn't specify fair, you can assume fair. Okay? By the way, the word die is the singular of dice, so you will not see me saying one dice is rolled. I have had students, I write one die is rolled. I've had students raise their hand and ask whether that's a dice. The word is die. One die, multiple dice. It's like mouse. Okay? I didn't make up English. Right? It's just the way it is. Okay. Okay, so I think the easiest way to address, rather than talk about general rules, the easiest thing to do is to just address problems and then see the rules as they come up, right? Usually the issue, students' decision-making comes up when you have multiple trials. It's an event that involves multiple trials. If it's one draw from something, then probabilities are just proportions, right? So, if it's one draw from a population and you ask what's the chance that the person is a woman, then it's just the proportion of women in the population. But the problem, students have to make decisions when there are multiple draws. And there I always say, just visualize the experiment and ask yourself a very simple question. What does the first draw have to be? The answer to that often determines what you are going to have to do. And so we're going to try that in what we're doing here. So I win a bet with chance 1 in 100 each time, regardless of all other times. And I want the chance of losing the first 3 bets. Now, I have this scheme that I follow. What does the first draw have to be? A loss. You agree? All agreed? Okay, I'm going to pause. Win a bet. You're given the chance of winning, and you're asked the chance of losing the first 3 bets, yes? The answer to what does the first bet have to be is a loss. Notice that I'm not talking about probabilities, I'm just talking about what it has to do. The minute you have said it's a loss, you can probably start writing down fractions of fractions, right? So what's the chance that it's a loss? 99 out of 100. Now, what does the second one have to be? A loss, regardless of what you got the first time, right? So what's the chance now? Yes, so the chance that both happen is a fraction of a fraction, 99 in 100 of 99 in 100. You see the method. It's not so much the answer, it's the method that you're focusing on. And that first question, what does the first draw have to be, is a much better question to ask than, is this a 1 minus problem? Much, much better, because it just gets to the logic of the event, and it's very simple. So you will get here, where am I? Here. So you'll have 99 in 100, 99 in 100, 99 in 100, and you see the italics, it's because it thinks that the star means something. Okay, look at that answer. You may leave an answer like that. You don't have to simplify at all. Yes? If your answer is 4 divided by 8, you will leave it as 4 divided by 8. You don't have to write equals a half. Okay, now, so same bet, chance of winning at least one of the first 3 bets. So I am going to pretend that I hadn't done the first problem, and I am going to follow the same process. I'm going to ask myself, what does the first bet have to be? Now, what's the answer? It could be a win, it could be a loss, yes? So now I know I have to do some more work, right? Just to settle ideas, at this point ask yourself, what does the second bet have to be? Either a win or a loss. So now you know that the ground is shifting a little bit. So now you have to try one of 2 things. Either list all the ways this could happen, or try the complement. Those are the only 2 ways you have at your disposal. So now this is the chance of at least 1 win in 3 bets, and so you could have 1 win or 2 wins or 3 wins, yes? And they could be in various locations, so you can write all those out, write the chance of each of them, and add up. Yep, that's fine answer. if you do the complement, you ask yourself, okay, they're asking me for the chance of 1 or 2 or 3 wins. You agree? If that doesn't happen, then how many wins do I have? 0. That's just one quantity. Hopefully I can find that. What's the chance of 0 wins? You just found it. So now what's the chance of 0 wins? You ask yourself, now for that, what does the first one have to be? It's got to be a loss. And then a loss and a loss. Right? And that is why you end up with this very neat little answer. But there is a thought process that went behind that. The point is here is not learning what the answer is, but how you arrived at it. And how you arrive at it is always, what does the first draw have to be? If I can't answer that cleanly, let me see, what does the second draw have to be? If I can't answer that cleanly, then either I have to partition the event in the different ways it could happen, or if I'm lucky, the complement is easier. And that's probability theory for you right there. Okay. So I'm going to ask you another question, and we are going to... Okay. Now, please, yourself. Now, today I'm going to not ask you to talk to your neighbor, right? Because on Friday you won't have your neighbor. So today I would like you to please take this problem, yourself follow the process that we just said, and write down an answer. And the process was, ask yourself, what does the first bet have to be? You have an answer? All right. So do you have sums? Do you have a 1 minus? Do you have a product? Which? Okay. Sums. Nobody's doing a sum. I'm glad to see that. You shouldn't be doing a sum here. Okay. So the fight is between a product and 1 minus. Yes? Right, ladies and gentlemen, what does the first draw have to be? A loss. What's the chance of that? Okay, the minute you can say that, your answer is almost ordained. What does the second draw have to be? All right, so notice that this is just a different way of asking the same question. All right? And you have to guard against looking at that word none and saying, I got to do a 1 minus. Right. Okay, so cards dealt from a deck. What is this? Heart followed by spade. Okay, so we have, the deck has 52 cards. Dealing is drawing at random without replacement. There are 13 spades and 13 hearts. And this will all be described for you, so you don't have to memorize. What these different aspects of cards are called are hugely culturally dependent. Okay, right. Our process, please. What does the first one have to be? Okay, so what's my answer? 13 out of 52. Don't simplify, and in this case, it actually helps not to simplify. What does the next one have to be? 13 over 51. Okay, notice, if you know what the first one is, that affects the chances of the second one. You're still multiplying. All those of you who have come from previous statistics classes and have associated multiplication with independence, disassociate right now. Multiplication has to do with putting multiple conditions on your event. All right. Next question. 2 cards from a deck, chance of 2 different suits. Same question or different question? Sorry? Same or different? Different question. Because I'm not specifying with suits. And I'm not specifying the order. Yep? Okay, ask yourself, what does the first one have to be? Anything. Okay, so now we have some work to do. Ask yourself, what does the second one have to be? Anything but that. Can you write down the answer for that? 13 out of 51, regardless of what the first one was, because they are balanced, those suits. Yes? And so now it's a product of fractions, except what's your first fraction? 1, 52 out of 52. Yes, different question because you have not specified what the suits have to be. Your chances are higher. I'm sorry. Different suit. Sorry. No. 39 plus 13. 52. Yes, okay. All right. So this is why I tell you when you can't answer what does the first one have to be, go to the second one. All right, your move. Go. What's the first one have to be? Anything. All right. What's the next one have to be? Anything but that. Can I write down that probability? Yes? All right, so then the first one. Anything but that. What you got? 39 in 51. Now, anything but the previous two. Yes? All clear? So what I want you to see is not so much the answer again. You see that the machine spits out the right answer if you just use the machine calmly. All right, we have 4 minutes. I have 3 problems. Perfect time. All right. You write down the answer to that question yourself without talking to your neighbor. So now I have an unfair coin. And the reason I have this is because in exam reviews, students always raise their hand and say, what if the coin were unfair? So here it is. What's the first one got to be? Anything. What's the second one got to be? Anything but that. Can you write down that probability? You can't, because it depends on what the first one was. Yes? So now, what are your options? There's a machine. The options are now either partition, write out the different ways it could happen, or look at the complement. Yes? That is the machine. Every single time, I'm going to try the partition. You agree that it's HT will work or TH will work? Yes? My answer is going to be bigger than the chance of each individual one. And so my answer is going to be 0.3 times 0.7 plus 0.7 times 0.3. Agreed? Okay. What if I had decided to do 1 minus? I could. The chance that the two faces are different, what's the complement of that? The chance that the complement is that they're the same, right? Now that they're same has to be partitioned because there could be 2 heads or 2 tails. Yep? And so you could also do it as 1 minus p, the chance of, which you now know how to do. All okay? So any of these is fine. All right, I have 1 minute for the one that blows people's minds. All right, number 8. I've got a deck of 5 cards. One gold star, not start. I'm going to deal 2 cards at random without replacement, and I want the chance that the second card has the gold star. If you were in lab, when they did probability, you've done problems like this before. The second card, what's the chance that it's a gold star? Is there a 4 in the answer? Did you go to lab when they did the probability problems? Okay, I'm going to take this apart and we're going to do a demo. This is a very important feature of without replacement sampling that was done in some detail in lab. Okay. 1, 2, 3, 4, 5. These are my 5 cards, yes? Imagine them shuffled. One of them has a gold star on it. You can't see which one. They're all shuffled. I'm asking you, what's the chance that this one has the gold star on it? Everyone clear? Okay, where could the gold star be? In any one of 1, 2, 3, 4, 5 places. If the deck is shuffled, is any one place more likely than any other place? No. So all the places are equally likely. The gold star could be in one of equally likely 5 places. So what's the chance that it's in this one place? 1 out of 5. 1 out of 5. And for those of you who are worrying terribly about this one, I hate to add to your worries before the exam, but you should be worrying 3 times more about these. Right? It cannot be the gold star if it's here, but it also cannot be the gold star if the gold star is here. Yes? So you have to figure out where could the gold star possibly be. It could be in one of 5 places. And the chance that it's in any given place is 1 out of 5. So please note that the place, which place it is, did not appear in the answer. It's how many places you know the distribution of.